Scalars and vectors. In this video, we are going to define scalar and vector quantities, resolve vectors into two perpendicular components, and illustrate unit vectors. Scalar quantities are physical quantities that only have a magnitude and no direction. Magnitude is just another way of saying size, which is measured in numerical value. For example, if a car has a mass of 2,000 kg, 2,000 would be the magnitude of the mass, and mass by itself doesn't have a direction. Therefore, we consider it as a scalar quantity. Other scalar quantities include distance, area, temperature, and time. Vector quantities, on the other hand, have both the magnitude and direction. This includes velocity, displacement, acceleration, force, and momentum. In order to represent vectors, we use arrow with the length of the arrow indicating the magnitude of the vector, and which way the head pointing indicating direction. Let's say we have vector A. Vector A is denoted with capital A and a small arrow, while the notation for magnitude of vector is as given. For instance, this is a vector for 6 km north. Thus, 3 km east would look like this because it's pointing to the right and it's only half the size of the 6 km. We can also have negative vectors. Any motion of vectors along the positive x and positive y-axis, they have positive values. Whereas, for negative values is for motions along the negative x and negative y-axis. Now, direction of vectors in 2D. Let's read the direction of these vectors. Number 1. Positive x, y equals to 0. Number 2. X equals to 0, negative y. Number 3. This is an angle vector. Can you read this one? Positive x, positive y. Number 4. Positive x, negative y. We need to resolve these vectors if we want to represent their magnitudes in x component and y component. Resolving vectors or vector resolution is a process where one vector is broken into two or more smaller components. By using trigonometry, we can calculate the value for the x component. For example, in this case, fx equals to f cos theta, and for the y component, fy equals to f sin theta. Example 1. A force of 800 Newton is exerted on a bolt A as shown in the figure below. Determine the horizontal and vertical components of the force. Solution. Firstly, we need to project the vector onto x and y axis. With the aid of trigonometry, we can find the magnitude of each component. For x component, fx is equals to negative 800 cos 35 degree equals to negative 655 Newton. The value is negative because the component is along the negative x-axis. Y component, Fy equals to positive 800 sine 35 degree equals to positive 459 Newton. The value is positive because the component is along the positive y-axis. We may write the vector f in the unit vector form, and that will give us vector f equals to negative 655I plus 459J, and the unit is Newton. But do you know what is a unit vector? Unit vector is usually denoted with small letter and a hat. Unit vector small letter a is a vector with a magnitude 1 in the direction of vector capital A. Unit vector has no units, and it is used for showing or pointing direction. Let's look at unit vector for three-dimension axis. The unit vector in the direction of x-axis is I, j for y-axis, and k for z-axis. Example 2. Write vector s in the unit vector form. Here we are given three-dimensional axis and vector s, where the magnitude on each axis is as shown in the diagram. The general expression for vector in the unit vector form is as given. Therefore, the answer for this question is the vector s is equals to 4i plus 3j plus 2k, and don't forget to put the unit. That's all for now. We'll continue in the next video.